Hello, welcome to the RC Wall Vacuum channel. So I'm back today with another update on this dyno, and this will probably be the last video I do on this. It's got a little bit of a post-mortem on the design, and any future videos would more likely, if there's going to be any, would be on SRE Customs once I get this thing over here. I've gotten a lot of the issues taken care of, and I'm going to give you a quick demo today of it running, and just go over a little bit of the issues I've had with the design if you're the sadomasochistic type that would want to build one of these. It might help you out with some info. So first of all, I wanted just a little message to Wade and Vance at SRE. I'd put you in a little table here for your fuel tanks. So for the 5T. I bolted it to the frame, so if you have to move it for your air cleaner, because I have it up there pretty close to the air cleaner. If you look over here, that may be a little too close for you, but it just unbolts and you can slide it around. Plus the tank can be moved around on there and rebolted if need be. But so that's ready to go. So a couple of design caveats I had initially when I started with this was I wanted to make it light and portable so it could be taken to race sites to do dyno testing right there. So to get to that, a couple of things I wanted to do is I wanted to make it out of aluminum to make it nice and light, and I wanted to have it battery powered. Now that presented two problems. Number one, I think the aluminum actually exasperated the vibration situation. I think if it had been a heavy steel frame, it probably would have absorbed vibration better. I'll get more into the vibration isolation in a second here. The other issue is the battery power. I was a little concerned about that initially because it doesn't give you any place to dump any of the energy from the EMI coming off the engine. So I've had to kind of abandon that. Power-wise, batteries would easily run this thing, but really need to have this frame grounded to the AC earth ground to pull off the EMI. And the EMI coming off this engine has been kind of annoying. I don't know if a twin's probably even worse. I did get some oscilloscope readings. I just hang a wire across the frame tied to the probe and can read it. It works as an antenna, and use that to kind of figure out where you got to get rid of some of the noise. A couple of things I did to mitigate some of that stuff was put a ground wire from the engine over to the frame. I did put an AC outlet on the and right on the side of the frame and tied the frame right to earth ground. Then I took the DC, the 0-volt return on the DC, and grounded that. Where I was having all the EMI issues, and almost exclusively was on the display. If you've seen the last video of this display, this thing would not even, the display would not even run in this room with this engine running. So that had a fluorescent backlighting on an LCD. So the fluorescent lights, I should have known that. Fluorescent lights don't like EMI from engines. I should have known that from my days of tuning Banshees and 250Rs in my parents' garage watching the lights flicker. So my first step was to actually replace that fluorescent backlighting LCD. I went to an LED backlight. It's the exact same monitor, and it's just got LED backlighting on there. But it's not, the image is not drawn with LEDs. The image is still an LCD, but it has the backlight for LED. I've not tried an actual, like an OLED display on this. So anyhow, that kind of helped it, but still didn't fix the problem. So then I started having, maybe it was cable issues. So I ended up switching to a much better cable. The cable I was under, the HDMI cable I originally had in there was the one that came off the Raspberry Pi. Truly not up to the task. So I did end up putting a much better shielded cable in there. I do have a fiber optics cable I was going to put in there and test it, but so far this is working without that in there. I may upgrade that sooner anyhow, or eventually anyhow. But as you see during the demo, there's still a little flickering at lower RPMs. As the RPMs come up, the display stabilizes, and so far I've not had it glitch out. So that kind of dealt with some of the EMI. Now, much to my amazement, I did not have any. I was fully expecting to have EMI with the microcontrollers and the small board computer and the sensor interfaces. I did use shielded wire, but we don't have no place for the shield to dump its noise off of. It wasn't doing any good, so that's another reason I wanted to put the AC earth ground onto the side of the frame. But surprisingly, I did not have any issues with the microcontrollers or the Raspberry Pi. Any of the sensor interface with the EMI. It was just that freaking HDMI going to that monitor. I don't know if it's the cable itself or what, but it is working a lot better now. So the other issue I had too is with vibration. I've gotten I'd mitigate quite a bit of the vibration. I'll never get rid of all of it because I mean you got the engine, you got the chain mechanism running and all that stuff. I did put some rubber isolators under the motor, and I got isolators under the bolts too to keep them isolated. Downside is you got to Loctite the motor in place to keep it on there. The circuit board's got isolation on the bottom of it now, and I got isolation on the back of this. It's just a rubber mat, and the nice thing about it is the rubber mat actually grabs them screws and keeps them from backing out. So there's still some vibration on these. I got rubber isolators under this for the keyboard, but it still wants to dance around. I'll probably Velcro the keyboard in place, and the mouse, if it's on a mouse pad, you really don't need the keyboard on there except when you set up parameters and stuff in there. So that's really where that stands. All the mechanical stuff has been, really haven't had no issues with that. The hydraulic's been flawless. When I do the run later, you can watch the gauge, you'll see it move around. I've only been able to get the thing to like 900 to 1,000 with this Dyno on here, and it maxes out. So that's a good sign. You should be able to run a lot bigger engines on this thing. And this flow control is pushed in almost all the way with this engine. So you get a bigger, higher volume pump or motor. Engine, I should say, you'll be able to, this thing will probably be out quite a bit farther and have a lot higher flow rates to be dealing with. So I'm going to toss in a clip of the oscilloscope view of this thing when I was running to show how much actual noise is on this thing. All I'm doing is I just basically put a piece of wire off the scope probe, drag around it, and it's not even grounded. It's not like a grounded dipole, so it doesn't really have all that good of efficiency as an antenna, but it still picks up a lot of noise on this thing. It gives you an idea of how much noise that these things actually emit. So the final thing I want to touch on before I do the demo is the reason I like this hydraulic setup is because it gives you both the ability to do inertia testing and also allows you to do variable load testing. You can actually break in engines on this, tune engines. You can get the thing set up, set the throttle where you want, go over here and play around with the carburetor, watch your ratings right there as you're tuning it. Versus like just a spin up one, you can run it and see how it works and then shut it down, retune it, and fire it again. So this allows you to move around like that. And as far as braking goes, you can vary the load on there, let it sit for a little while, change the speed around, change the load around, and break in the engine right here on the machine itself. So anyhow, let me spin around and we'll give a quick demo.